Hi, my name is Terry, and in this video we're going to take a look at some double integrals that need us to change the order of integration. Let's take a look at the example on the board. This example over here on the board, example number 1, the outside bound 0 to 8, and then we're going from the cube root of y to 2, e raised to the x to the 4th dx dy. So dx dy, this is an iterated integral implying to us that we need to integrate with respect to x first, then y. But e raised to x to the 4th power, you can't integrate that. Okay, we can't do that using our methods that we've learned. So what do we need to do here? Well, instead of integrating with respect to x first, then y, this is a dx dy problem, we need to switch the order. We need to integrate with respect to y first, then x, okay? But you have variable bounds here, so you're going to have to sketch the base to see how are we going to take the y bounds and write them as a function of x instead of in terms of y. So let's go ahead and we're going to sketch the base. So in terms of x, your lower bound, okay, so in terms of x, your lower bound is the cube root of y, so x is the cube root of y, and then your upper bound x equals 2. All right, so see, these are the boundaries. These are two of the boundaries of our base, okay? And then the y's go from 0 to 8. So let's go ahead and just sketch what we have right here, okay? So what does this look like? Well, x equals the cube root of y. All right, so let's take that first, okay? So x equals the cube root of y. Well, let's go ahead and get this in terms of y equals. So cube both sides, okay? So when I cube the left and I cube the right side, y equals x to the 3rd power, okay? So y equals x cubed. Here's my x-axis, here's my y-axis, and I'm sketching out my base. So y equals x to the 3rd power. This is what y equals x to the 3rd power looks like, okay? And then the upper bound, the other part of that, so is x equals 2. So x equals 2 would be over here. These are part of my boundaries, okay? So x equals 2, all right? And when x is equal to 2, y is equal to 8. So this point right here is 0 to 8, okay? So you can see the inside bounds are going to travel from the cubed curve, to 2, and the outside bounds are going to go from 0 to 8, all right? So this is our base right here. All right, described by the bounds, this is what the base is, all right? The way this is set up, dx dy, if you recall when we were setting up double integrals, this dx dy is describing a type 2 region with the inside bounds being in terms of y and the outside bounds being in terms of x. What we in turn need to do is change our type 2 region to a type 1 region. We want to rewrite this, but we want to rewrite this so it's a type 1 region. All right, and so what is our curve up here? Well, type 1 region, we're going to write y as a function of x. So this is y equals x to the 3rd power, all right? And the x-axis right here is y equals 0, all right? And you can see that this from the origin, and you can I've labeled here where the intersection points are. So changing the order of integration, all right? So we want to change the order of integration here. So you have e raised to the x to the 4th power. This is our integrand. Right, this is our integrand, but as we can see, we cannot integrate with respect to x first. We need to integrate with respect to y first, okay? So we need to have a dy dx. It needs to be dy dx, okay? So your y bounds, the inside bounds are going to be y equals as a function of x. We're going to change the type 2 to a type 1, so can you see we're going from 0 to x to the 3rd power. Your inside bounds are going to be translated from 0 to x cubed. There's your inside bounds. Right? And then your outside bounds, dy dx, your outside bounds could be horizontal. You're going from 0 to 2. 0 to 2 would be your outside bounds. So to change dx dy, to reverse the order of integration, to help us with the integration portion of it, this is the process. You want to just look at the bounds, sketch your base, and you're going to change a type 1 to a type 2 or a type 2 to a type 1. That's what the idea is. So you'll have to rewrite your functions in terms of x or in terms of y. You'll have to turn it around and set it up again. All right? And then we can go ahead and evaluate, okay? So just be careful setting it up. Now we will evaluate. You're going to integrate from the inside to the out. Now we have no y's in the integrand, so e raised to the x to the 4th would be treated as a constant because we start by integrating with respect to y. So integrate with respect to y, so here the bounds 0 to 2. Integrate with respect to y, you're going to have y times e raised raised to the x to the fourth power, and this is going to be evaluated from 0 to x to the third. All right. Fundamental theorem of calculus. Okay, so we'll take care of the dx in a moment, but fundamental theorem of calculus, you're going to plug in the upper bound, x to the third e raised to the x to the fourth power, minus when you plug in the lower bound, you have 0. All right, so, and then we're going to evaluate this with respect to x. When you evaluate with respect to x, we're going to utilize a u substitution. So let's let, with the exponential function, we're going to let u equal the exponent. And then we're going to take the differential. So the differential is the 4x to the third dx. All right, and so, and when we rewrite this integral, your x to the thirds are going to cancel. All right, so your x to the thirds are going to cancel. And so you just have the 1/4, and you're integrating your e to the u, because we're going to substitute u's in. All right, so this will give you 1/4 e raised to the x to the fourth power when you do your integration, and this needs to be evaluated from 0 to 2. Okay, so from 0 to 2. All right, and so plug in the upper bound, so 1/4 e raised to 2 to the fourth power, so 2 to the fourth power gives us 16. All right, subtract to that 1/4, okay, times e raised to the 0 power. Any number raised to the 0 power is 1. So here is your solution for the iterated integral portion of it. So reversing order of integration. Sometimes it is necessary to reverse order of integration, okay? One of the key times when you have an integrand that's not possible to integrate, so instead of the dx dy, sometimes it's just necessary for you to do the work to dy dx to change it around. So type 1 to type 2 regions, sometimes you have to move them back and forth, change them around, so we can manage to solve it. All right, so this is an example, reversing order of integration, and I hope it helps. Thank you for watching. Stay safe out there. Stay healthy. Thank you again for watching.